Hello Year 10, it's been a long time since we've seen each other and you've had a lot of lessons with nobody teaching you really. So this is a recap of all the radioactivity stuff. You may take 2 or 3 hours to go through it all. The first thing you're going to do is you're going to work from the worksheet and you're going to answer the first 12 questions, or you're going to try to answer the first 12 questions. You may not be able to do them, it doesn't matter. Just have a go at them and put a cross if you can't do them. Okay, so do that now and then just pause this video whilst you do them and then restart the video and I'll quickly go through the answers. Okay, so pause it now. Okay, let's go through them then. So number one, the old plum pudding model of the atom assumed that atoms were solid with a solid mass of positive with little electrons dotted about through them, rather like a plum pudding. How did Rutherford change the plum pudding? How did his discovery? Well, he found out that atoms were actually mostly spaced. They're just hollow with tiny, can't say tiny enough, nuclei, a nucleus right in the middle. So he found that atoms were mostly hollow. Number three, what do the top and bottom numbers mean? The top number is the mass number, the bottom number is the atomic number, or the proton number. Number four, how are two isotopes of the same element similar, different to one another? They always have the same number of protons, otherwise they're not the same element, but they will have a different number of neutrons. Number five, ionizing means the radioactivity has enough energy to knock an electron off an atom or to push an electron onto it, making it an ion, hence the name ionizing. Number seven, which form of radioactivity is most or least penetrating? Gamma is the most, followed by beta, and alpha is the least. Number eight, what is the mass of an alpha particle and the charge on a beta particle? Okay, the mass of an alpha particle is 4 and the charge of a beta particle is -1, sorry, it's just an electron, -1. Number 9, which form of radioactivity is a wave? Gamma radiation is a wave, it's not a particle, it's totally different to the other two in its makeup. Number 10, what is an alpha particle similar to? It's identical to a helium nucleus. Number 11, what happens to the mass and atomic number when a nucleus undergoes alpha, beta and gamma decay? Alpha decay, the mass number goes down by 2, the atomic number goes down, sorry, the mass number goes down by 4, the atomic number goes down by 2. With beta decay, the mass number stays the same, but the atomic number goes up by 1. And gamma decay, there is no change. Nothing happens. It's exactly the same as before. The two numbers are. And number 12, if the activity of a radioactive sample is 64 and then 3 days later it is 32, what will the activity be after another 9 days? Well, it's gone from 64 to 32. That means that's half. It's halved. So that is its half-life, those 3 days. Okay, so after another 9 days, it will half again and again and again. So it'll go 16, then 8, and then 4. So 4. Okay, now I'm going to end this video and I'm going to do a little bit more explaining. If you just actually pause the video, and I'm going to explain things in a little bit more detail now. Okay. Right. Let's go down to. We'll go down to the explanations now. If you don't need the explanations, you can just skip this video and try and do the next few questions that are at the bottom of the page. Okay. So number 1, the plum pudding model of the atom. Right. That's everybody assumed atoms were solid. Now we know there's electrons going around, but of course, why would you think electrons are going around a nucleus? It seems silly. So they were assumed to be completely solid. And when he fired these little particles at a thin, when Rutherford fired these tiny alpha particles at a sheet of gold, very, very thin gold, some of them went straight through it. Now gold is not transparent, there's no gaps that we can see, but the particles went straight through it. And just a few were deflected back. So when those few particles got close to, as they approached it, when they got close to the nucleus, they were positively charged, these particles, they were repelled backwards. Okay, So that changed everybody's thinking. We suddenly realised that it was just space, atoms really, and there's a tiny dot in the middle. Okay, the top and bottom numbers of the periodic table. The top number, very importantly, the top number is the mass number. Okay, so that's the number of protons plus neutrons. I'm going to do the rest of this video looking down at a piece of paper. Got a piece of paper, please, so that you can see clearly. Okay, so I'll switch that to that view. Okay, thank you. Okay, right. So if we've got two numbers here, if we've got a number like helium, for example, helium 4,2, that means the nucleus has got 4 particles in it altogether. The mass is 4, and 2 of those are protons, which means the other 2 must be neutrons, because there's nothing else in there. Okay. Just going back to question 5 now, question 5, ionizing. Imagine an atom with the nucleus there, which is basically all this lot. The electrons are going around the outside. If a radioactive particle comes along here and hits one of those electrons and knocks it off, this becomes an ion. So we would say that it's ionizing radiation because it's capable of ionizing the atom. Okay, so it's a bit of a tricky one. People always forget what it means. But once this atom has got a charge and it's lost an electron, it's ready to react with something else. Now, that doesn't really matter unless it's in your DNA. And if it happens to hit a critical part of your DNA, this can be pretty serious and cause health problems or kill the cells. Okay. And then the next one was, not an isotope, it was, we looked at the periodic table. The mass of, let's go to penetration. Okay, I made a video on that. So if we have an alpha particle, the alpha particle will be stopped just by air or by paper. Okay, paper. But beta would go straight through air and straight through paper. It needs something like aluminium to stop it. All right, 2 millimeters of aluminium will stop it of a metal. And gamma radiation will go straight through anything really, even lead. It has to be quite thick lead to absorb gamma radiation. So gamma is the most penetrating, followed by beta, followed by alpha. Which form of radioactivity is the most ionizing? Well, alpha has got a charge of +2, so it's very ionizing. Beta has got a charge of -1. It doesn't matter that it's positive or negative, just the fact that that's got a 2 charge. So as it goes past that electron here, it's going to attract the electron away. The negative will repel it away. But the stronger the charge, the greater its ionizing potential. Okay, and gamma has no charge, but it can just about knock electrons out. Gamma can knock electrons out. It's like ultraviolet can X-rays, but gamma is more so than X-rays. Okay, and which one is a wave? Well, as I say, these are particles. This is a particle, and this is a wave. This is totally different. So gamma is a wave. What is an alpha particle similar to? It is identical, but it has exactly 4 nucleons. That means particles in the nucleus. It has 2 protons and 2 neutrons. If you added electrons around the outside of that, 2 electrons going around, it would be a helium. It would be a helium atom, but it's a helium nucleus. Okay. What is the atomic and alpha particle? So we've said that. Number 11, what happens to the mass and atomic number when nucleus undergoes alpha decay, beta decay and gamma decay? I've made a video on this already, which you can look at. But basically, if you have an atom there that's made of protons and neutrons, if it suddenly splits, it will give out 2 neutrons, 2 protons with alpha. This is alpha decay. So there's a total of 4 less. So the mass number goes down by 4, and 2 of those are protons. So the proton number, or the atomic number as it's often called, goes down by 2. Loses 2 of those, 2 protons and 2 neutrons. So 4 altogether, and 2 of them are protons. So that has those 2 numbers there. And finally, beta decay. Beta decay is when a neutron suddenly decides it wants to be a proton. So we've got the neutron there, and it suddenly becomes a proton. So we cross that out, we add a proton. That means the atomic number's gone up by 1. There's 1 extra proton. So the atomic number goes up by 1, but the mass number stays the same. There's no change for the mass number. Okay, it's just the same. And gamma decay, nothing happens. They just move around in here. There's no change in atomic number or mass number. Number 12. If the activity of a radioactive sample is 64, and then 3 days later it's 32, what will the activity be in another 9 days? We've looked at that one already, haven't we? Okay. Now I've added some video links. Okay, I'll put those on the worksheet. They explain these points in more detail. Have a go at the video links and then try to do the questions, the following questions, which are at the bottom of the page there. I'm just scrolling down to them now. Okay, and then I will do another video that goes through the answers to the 11 questions. Okay, so have a go at those 11 questions now, and then I'll do a quick video that goes through the answers.